Good morning to all. I hope everyone are happy and healthy. And after a long gap, we completed successfully the 2 phases of Gnaanadeeksha, and congratulations to one and all. Now today we entered into the 3rd phase. So welcome you all and a special welcome to our mathematics subject. Now after a long gap, today I came out. So on the way to the studio, I keep on observing so many things outside the nature. So I travelled along the tank bund. I keep observing our Indian national flag, and I observed the zebra crossing where the people cross the road, current poles, and a beautiful lane with so many trees which were placed in a particular sequence, and a stadium, and a beautiful nursery, and a traffic signals, and so many places like monuments, buildings, apartments, and very crowded places. So children, did you notice among these 2 slides, if you observe, many of the things which were there, which were existing on our planet Earth are made up of so many shapes, and those shapes belongs to our geometry. So we need to measure these all shapes at any time. So measuring the real life things which are existing on our planet Earth, that is nothing but our geometry. So completely geometry deals with the measuring the real life things which are existing on our planet Earth. So if you keep on concentrating on all these shapes, each shape is formed either by using any of these things like point, lines and line segments, rays, parallel lines, intersecting lines, perpendicular lines, planes, angles, polygons, and many more things from the geometry. So now let me explain for you. We will all discuss together all the basic concepts from the geometry. And we all know that geometry came from 2 Greek words, that is geo and metron, which means that earth measures. So as I already said for you, we need to measure each and everything which were existing on our planet Earth, which is related to our geometry. And the next one, now we will discuss in brief about the 4 things: point, line, line segment and ray. So if you see the second one, here I kept a small point. I represented with the letter O. So this is the point. Point determines a specific location. Point determines a particular place. Point doesn't have any length, any breadth or any height, any width. It means point doesn't have any dimensions, and we will represent always points by using the English capital alphabets. For example, if I want to show you, the tip of the marker is an example of a point, and tip of your pencil is an example for the point, tip of your pen is an example for the point. And when we talk about the board, the corners of the board represents the points, corners of your room represents the point in our real life. And if you see the first one, it is a straight line which extends in both the directions indefinitely without having any end points. It is called as a line. It is called as a line. Line doesn't have any end points. It extends in both the directions indefinitely, and we cannot measure a particular finite length for the line. And symbolically, we can denote line as PQ and a small line symbol upon the PQ. This is the symbolic notation for denoting the lines. And points, I already said, we have to use the English capital alphabets like O, A, B, C, so on. Any English capital alphabet you can utilize for the representation of the point. And next one, if you see the 3rd figure, RS. I am joining any 2 points from R to S. It means a particular length I am taking. It is a part of a line. From the line itself I am taking starting point and ending point which contains, it is called as a line segment. And everybody knows segment means it is a part. From where we are taking the segment? From the line we are taking the segment. So a part of a line having the starting point and ending point is called as a line segment. Symbolically, we can represent the line segment as RS and a small line segment symbol upon that. That is the symbolic representation for the line segment. Take the next one, 4th one. So 4th one, it is also a part of a line having one end point and which extends indefinitely in the other direction is called as a ray. Now let me explain for you real life where we will use these things. Next one, plane. If you see this slide, I am keeping plane, I am also keeping a table beside that. What is the relation existing between both of them? Did you observe the surface of the table? It is exactly flat. It is exactly a flat surface. Now observe the surface of your notebook. Observe the surface of your roof. Observe the surface of your floor. Observe the surface of your plate. Anything if you observe which is flat and smooth surface, we will be calling it as a plane. Now next one, if you see the slide, I took a pencil, or if I take a marker, or if I take a scale which we can measure a finite length. If it is having a finite length, it is called as a line segment. So for all line segments, we can measure by using the ruler or scale or meter tape, etc. We can find out the definite length. And next one, if you see, I took a road as an example for the line, because when you take a line, it extends in both the directions indefinitely. We don't know where the road started, we don't know where the road ends. Of course, the roads will have a proper starting point, but further it may extend to some other destination. Similarly, we cannot say particular length for the road. It will be going on extending in both the directions. So that is the reason we can take the road as an example for the line. Now next one, the beautiful image, sun rays. So I hope you understood these real life examples of sun rays and torchlight rays are the examples of what? They are the examples for rays. So whenever we define the ray, it has a starting point and from there it starts extending indefinitely in one direction. It means this starting point is called as origin. So when you consider our sun rays, sun is our origin. From sun, the right rays reflects. So sun rays, torchlight rays, our electric bulb rays, these are the examples for the rays. Can you tell me what is one more example which we get in our human body for the ray? In our human body, we will get the example for the ray. Can anyone guess it? What is that? Yes, it is exactly that, our hair. If you consider our hair, it starts and it's keep on extending. It is having the origin on our head. Now see one more example. I given a beautiful the hut which is drawn by a small baby. Now you can see here clearly in this picture, we are using point, we are using the line segment, we are using the line, we are also using the rays. So this is the exactly real life example where we can use all the shapes. So all the corners of the house denotes the points and all the edges of the house, they are the line segments. And you can see the base of the house which is extending indefinitely in both the directions. I given two arrow marks. It means there were many houses placed right side, left side, right? So that is the reason here I took as a base as a line. Then what is the smile face? That is sun. Means it is an example for the ray. So in our real life, day-to-day life, we will be coming across all the four things: point, line segment, ray and plane, knowingly or unknowingly. Now let me move to the next point. Types of lines. Clearly you can see in these three pictures, parallel lines, perpendicular lines, intersecting lines. So if you see the first one, I took two lines vertically. It means these two lines will never meet, will never intersect each other. And if you observe children, the distance between these two lines is equal anywhere. So if two lines in a plane which never meet, which never intersect, they are called as parallel lines. And next one, if you see here, these two lines intersecting at a common point here. They both are intersecting at a common point. If I am taking two lines in a plane and if they intersect each other at a common point, they are called as perpendicular lines which making 90 degrees angle. Now all of you observe towards the board what I am drawing here. What is the difference between these two figures, children? Did you notice what is the difference between these two figures? these two lines also intersecting at a common point, and these two lines also intersecting at a common point. But did you notice the difference? Here the angle is making 90 degrees, but here it may or may not be 90 degrees. So these lines, if I take line L and line M, these two lines are called as intersecting lines, and intersecting lines which are making angle 90 degrees at the intersecting point, then those two lines we call them as perpendicular lines. Now let me move to real life example. See the first picture, railway track. Railway track is the best example for your parallel lines. Wickets in the cricket is also example for your parallel lines. Current wires, electrical wires is also example for your parallel lines. And the best example for your parallel lines is your notebook. Our notebook is also the best example. The lines which were there in our notebook is the best example for parallel lines. And one more example also, can you see the red color carpet here which is there with the two white color lines? That is the track for athletic people. People who participate in athletics, they need to run like 100 meters, 200 meters, 300 meters. The people run. They take part in competition. So for those students also, we will be having the parallel tracks. And if you see here the antenna is also an example for parallel lines. And if you see the next picture, can you see here beautiful towers, two parallel towers, and two vertical parallel towers, two horizontal parallel towers. So many of our historical monuments are built, they constructed by taking the help of parallel lines, intersecting lines, perpendicular lines. And if you observe in these two pictures, in the middle picture the vertical lines are parallel and horizontal lines are parallel. But when a vertical tower is attached to a horizontal tower, what did you notice, children? I hope you understood what is the relation existing in the figure. Yes, these two lines, vertical as well as horizontal, are perpendicular to each other. Similarly, in the first figure also, a dam is constructed with a pole, right? And so this vertical pole with the horizontal dam, both are perpendicular to each other. If you see the third one, everybody know what is that, right? It is a chaurasta, it is a traffic signal. So here also, if you see blue color lines, both are intersecting and making an angle 90 degrees at the intersecting point. So this is an example for perpendicular lines. Hope you understood in our real life where we come across parallel lines, perpendicular lines and intersecting lines. Now, see the next one. Rail crossing and a scissor I took. Children, did you notice any time whenever we go to a danger road or any forest places, most of the places they will be marked with into, like intersecting lines. It means it denotes that we are not supposed to go there. Red zone area, danger route, roads are closed, work is under progress. Many times they use this symbol and they will write that notations. It means what? We are not supposed to go towards that road. So this is one example which I given here, railroads crossing. It means you are not supposed to go, or so and so work is going on there. And Caesar, if you take red color lines, did you observe here? These two red color lines are intersecting each other and meeting at a common point O. So this is an example for intersecting lines. Hope every day we are using all the geometry in our real life, right? Now, let me move to the next concept. First figure you observe. I am focusing on the wheel, children. So I hope what is that vehicle is called as? Cycle. Everybody interested to ride the cycle in the early morning, right? So if you see this wheel is an example for congruent lines. So making you understand, let me ask you a question. I took a point here. Now tell me how many lines we can draw passing through that point. 1, 2, 3. 1, 2, 3, 4, so on. So I am drawing 3 to 4 lines here. Can I draw still more lines? Yes, it means infinite many lines can be passed through one point. So all these lines are called as concurrent lines. These lines are called as concurrent lines. So best example is our cycle wheel. So from one point many lines can be passed. See the next picture, second picture. I took an electric pole where so many connections were given on one pole. It means what? They are nothing but collinear points. So generally, if two or more points lying on a one line, I am taking point A, I am taking point B, I am taking point C, I am taking point D, E, F. If you see this picture related to the second image, A, B, C, D are collinear points, and if you see E and F are non-collinear points because these 2 points are not lying on the line. So for this example is our generally electric pole or antenna or any current related dishes. If you take, so many points are connected to single line, and very good example I want to give it to you to get the entertainment, that if you visit any function, if you go to any housewarming celebration, how the house is decorated? Yes, imagine little bit. Yes, the house is decorated with a full of lights. Did you anytime observe how the bulbs are connected? They are connected to a single wire. To one wire, many bulbs are connected. So that is also an example for collinear points. So second one also is an example. All the bulbs are connected to one line. You can see the red color line, and all the blue color pinpoints you can see, these are also example for collinear points. One more example I want to give it to you, that in our nature, birds sitting on a current wire. Whenever we go outside for a traveling, we keep on observing outside how the birds sit on an electric pole. So they sit one after other on one line, single line. So that is also example for collinear points. Now next. Right, very beautiful image. Like we are having a lot of greenery and seeds, right? Coplanar points and coplanar lines. So I want to explain for you before the slide. If you take a plane means it is a flat surface, and if you take a plane, I am taking points inside like A, B, C, E, D. Now points which belongs to the same plane are called as coplanar points, and points which doesn't belongs to the same plane are called as non-coplanar points. Similarly, if I take the lines, line L, line M, line N, lines which belongs to same plane are called as coplanar lines, and this line is outside the plane, this is called as non-coplanar line. So the good example is our agricultural field. If you see our agricultural field here, all the seeds which we keep in our plane. Suppose if I have a 1 acre of land, I will keep seeds only in my land, not to other land, right? So keeping seeds in our particular land is coplanar points, and the crops which grow in our land, that is the example for coplanar lines. And one more example for this is coplanar lines and coplanar points, our sports. Everybody will get interest to play the sports, right? And we are all loving to observe the sports players, and when they are playing, we are very much interested. So just imagine how the stadium will be. All the players will be considered as the points, coplanar points, and the tracks which we keep in that particular plane, we call it as coplanar lines. So this is the example for athletic track. So all these lines are parallel, as well as some intersecting lines are there, and this is a good example for coplanar points and coplanar lines. Next one. Yes, what is this picture? This image is protractor, as everybody know. So now we are going to discuss about the angles. So what do you mean by angle? What do you mean by angle? The union of two rays forms an angle. The union of two rays forms an angle. What do you mean by union? Union means joining, combining. When we keep together, we will call it as union. So when we draw the picture of angle, I am taking a ray OA, I am taking another ray OB, I am joining both the rays. So here it formed an angle. So this vertex where the angle formed is called vertex. O is called as vertex, and OA is called as initial ray, and the ray OB is called as terminal ray. Initial ray, terminal ray where the angle formed near the point O is called as vertex. So whenever we discuss about the angles, types of angles, the angle which is exactly 0 degrees is called as zero angle. The angle which is exactly 90 degrees is called as right angle. Angle which is greater than 90 and less than 180 is called obtuse angle. Angle which is exactly 180 degrees is called straight angle. The angle which is greater than 180 and less than 360 is called reflex angle. When I complete one full rotation, this is an example for 360 degrees angle. But we have to know where we are using this angle in our real life. If you see the next one, constructions. Most of the angles we will be using in construction field, constructing the dams, constructing the bridges, constructing the monuments, constructing the roads, railways, metro stations, everywhere we are using the angles concept. So major part we are using in constructions, the next in surveying the fields, in navigation, in astronomy, etc. Next one, day-to-day life we use angles in tailoring. In tailoring also we will be using angles. A tailor person, the person who stitches will make use of different angles according to the different measurements. Similarly, a barber, people will go for haircut. So a person will take the help of different angles for different haircuts. Next, apart from this, we also use the angle in playing the snooker games, in clock, in windmills, in building the in many historical monuments. Next one, adjacent angles, linear pair angles, vertically opposite angles. See these two figures, children. Adjacent angles, adjacent means she is sitting adjacent to me, will say generally. Who is there? Next to me. Similarly, adjacent angles having a common point, common vertex and a common arm. You can see in the blue color figure here, adjacent angles are two angles which are having a common point and a common arm. They are called as adjacent angles. So it can be two angles, it can be three angles. So the angles which are side by side, they are called as adjacent angles. If you see the next one, linear pair angles also having two angles. Pair means two, it indicates two. So here also we can take a common vertex, common arm. But what is the difference between the first image and the second image? Did you notice? Yes, it is linear pair angles always forms a straight line. It completes 180 degrees. So that is the difference between the adjacent angles and linear pair angles. Linear pair angles are adjacent angles, but adjacent angles are not linear pair angles. Now next one is vertically opposite angles. When two lines intersect each other, you can see here these two lines are intersecting. We get completely four angles. So these two where I given marking with the sky blue color, these two angles are called as vertically opposite angles. But where we use this adjacent angles, linear pair angles, right? A beautiful picture which is tempting. That is pizza or a cake or any bun. If you cut these two angles 52 degrees, they are equal of course, but they may not be equal, they may be equal. These two are called as adjacent angles. Whereas if you see the Caesar here, two lines are intersecting, angle A, angle B, they are linear pair angles because it is forming a straight line. Linear pair angles have common vertex, common arm, but they forms a straight line. And next one, complementary angles and supplementary angles. What do you mean by complementary and supplementary? Observe the figure. Angles that add up to 90 degrees. It means simple. When two angles if you take, if you add them, you must get 90 degrees. So sum of the two angles is 90 degrees. They are called as complementary angles. If the sum of the two angles is 180 degrees, they are supplementary angles. Children, if you notice, supplementary angles are linear pair angles. Did you observe? The two angles when you add it is forming a straight line. They are the examples for linear pair angles. Now the next concept is, if you see the real life example for supplementary angles and complementary angles, ladder. Did you observe this picture, ladder? I am keeping the ladder to the wall. Angle A, angle B. Below the ladder, above the ladder, it is completely forming 180 degrees. So this is an example for supplementary angles. Next one, if you see complementary angles, when the time is 3 o'clock, when the time is 9 o'clock, did you observe the angle before the seconds hand, after the seconds hand, it is 90 degrees. So, in real life, knowingly or unknowingly, children, we are using in many places supplementary angles and complementary angles. Next one, right. See this picture, antenna, the wall, the tracks, any monuments. If you observe all the 4 pictures, children, 2 or 3 lines we are taking, and a line is passing through these 2 lines, L, M, N. 2 parallel lines, or they may not be parallel lines. This N is called as transversal. So, in the next class, again we are going to continue with the same topic. Thank you.